Alright, simplifying exponential equations and expressions. Here are two of the basic kinds of equations and expressions we will cover and you will see next year as well. First one on the left is an equation simply because it has an equal sign. The one on the right is an expression, variables, terms, everything, but no equal sign. On the left hand side we have variable b that we need to solve for. So we need to simplify that. When your bases are different, you have 625, 25, and 125, can't do anything with them. So we need to change the bases, if we can, in order to simplify this. Luckily enough for us, 625, 25, and 125 all have the same base of 5. So 625 becomes 5 to the 4th power. You change the look, but not the value. 25 becomes 5 squared. Again, you change the look, but not the value. 1 over 125, well, 5 to the 3rd power is 125. Since it is in a fractional form, it must be 5 to the negative 3 power. So remember, negative power doesn't mean a negative number. It means a small number. It means a fraction. So now we have the same bases of 5 for all three numbers. So now we can take a look at the exponents and solve them. So we have 5/4 to the b power. When you have a power on a power, well, we multiply those powers because there's exponents mean multiplication. So the next step is 5 to the 4b power times 5 to the negative 6b, which comes from 2 times negative 3. The last term, 5 to the negative 3 power, is nothing to change there. So now that we have all the bases the same, we don't need to look at the bases, we just need to look at the exponents. So 4b, negative 6b, negative 3, we look at those. That's where I put the arrows. When you're multiplying bases, the exponents themselves must be added. Okay, so now that goes back to, well, that goes back to like day one of our exponential studies. Now you get 4b and negative 6b is simple. It's like this. So if you have x squared times x to the 3rd power, well, you combine the exponents by adding to get you x to the 5th power. Here, we're doing that as well. We're adding 4b plus negative 6b, and that gets us negative 2b equals negative 3. And we do our normal algebra. Negative 2 is being multiplied to the b, so we do the opposite, which is division. So we divide by negative 2 on both sides. And we're left with b on the left, and negative divided by negative is positive. 3 over 2 we can leave as 3 over 2, and that is our answer for B. Now let's move to the expression, and I just would follow it just like PEMDAS, order of operations. Even though here we can actually take several routes, I would stick to the one that we know the best, which is PEMDAS, our order of operations. So I'll take a look at the parentheses first and clean those up. So in our in the numerator, we have this parenthesis, we have it twice because of this. So everything doubles. 2 becomes 2 squared. X to the negative 1 becomes x to the negative 2. Y squared becomes y to the 4th because you distribute the 2. Or if you think of it, you have that parenthesis twice. That means 2x to the negative 1, y squared. You have it twice. So everything, if you expand it out, look at this, 2 happens twice, x to negative 1 happens twice, y squared happens twice. That's why all of these numbers double. All right, in the denominator, oops, shouldn't have done that. In the denominator, everything triples. So x to the negative 1 power becomes x to the negative 3. Y to the 3rd power becomes y to the 9th. The next step is we have a lot of the same bases in the numerator. Let's combine those bases, just like you organize all your socks into one drawer, organize all your bases together. So we count how many 2's we have. We have 3 of them. Count the number of x's you have. We had 4, then we have negative 2. 4 plus negative 2 is just 2. Y to the 4th, that's the only y base there in the numerator, so we leave that alone. In the denominator, well, things stay the same. Now we need to clean up the numerator and the denominator together. I circle these two because there are x's in the numerator and the denominator, and there are y's in the numerator and the denominator. You have to figure out which is the best place to put them. You definitely don't want to end with negative to exponent, so I'm going to move the x to negative 3 to the top. I'm going to actually move the y to the 4th, even though it's positive, I'm going to move it to the denominator. And you'll see why in a second. So our next step, in the numerator, 2 to the third, x squared, x to the third power. In the denominator, y to the ninth, and y to the negative fourth power. In the numerator, when you combine all those, while 2 to the third power stays the same, we now have 5 x's, so x to the fifth power. The y's become y to the fifth power. Why move the y to the fourth to the bottom versus y ninth to the top is, well, if you move the negative 4 down to the bottom to make it negative 4, you still end up with a positive exponent on y, and that's what we want to end up with in the last place. So that is your answer there. Or you could expand it out. 2 to the third power is 8. So you could have that as the actual final answer as well. All right, good luck. Signing out.